Welcome to the first episode of our self-driving car series. In this project, we are building a small autonomous vehicle that can see, think, and drive all on its own. Uh, Unlike basic line following robots or vehicles that use light sensor or uh, other stuff, our car will work with real-time images and convolutional neural networks. Uh, yeah, the camera will capture what's in front of the car, and based on that input, the neural network decides whether to go straight, turn left, or turn right, backward uh, as well. In this video, we'll go over all components you need to build it from scratch. So let's get started. We begin with the chassis, a four-wheel platform with no steering. The car turns by adjusting the speed of the wheels on each side. To control the motors, we use the L298 and motor drivers. We are going to use two. Each one handles two wheels, giving us control over direction and speed. Uh, for power, we use two 3.7-volt lithium batteries, which provide enough energy to move the car smoothly. The batteries go into a battery holder that keeps everything organized and secure. Um, Also, we use a 120 watt USB-A to USB-C cable to deliver reliable power to the Raspberry Pi. Jumper wires and connecting cables are used to wire everything together: power, motors, GPIO pins, and more. For storage, we install a 128 gigabyte micro SD card. It holds the operating system code on the data we'll collect. Also, the 2000 milliamperes power bank supplies electricity to the Raspberry Pi separately from the motors. This power bank is 50 watts and made by the Manker. The Raspberry Pi 5, of course, with 8 gigabytes of RAM, handles everything. It reads the camera input, runs the neural network, and controls the motors. And yeah, for vision, we are using a 8 megapixel camera which captures light images for the neural networks to analyze. Yeah, important. To prevent overheating, we need to add a cooling fan with the heatsink on the Pi. Uh, yeah, and also the camera is mounted on a tilt support, so we can adjust the viewing angle depending on the setup. And finally, a wireless mini keyboard help us interact with the Pi during testing and setup. Yeah, here we have all the components. This is one image in the construction, and this is the final result, all the components together. Um, yeah, and that's it. Now let's jump into the process of assembling all the components step by step. Before starting work, it is necessary to see the diagram of the components to see how will be connected. In this diagram, we can clearly see how all the components of our self-driving car project are wired. On the left side, we have the GPIO pinout for the Raspberry Pi. It highlights exactly which pins are used to control the motors through the L298N motor drivers. And below it, uh, we have this table uh, showing which GPIO um, GPIO pin control its motor's directions and speed, which enable pins are used, and the color of the wires um, for quick identification during the wiring process. For example, the front left motor use GPIO 9 and 11 for direction and GPIO 25 for enable. Uh, on the right side, we have a complete wiring diagram. Four motors are connected to two L298N drivers. Um, yeah, the L298N drive motor drivers receive power from two 3.7 volts lithium batteries connected in series. Um, yeah, with a switch in between to control the power delivery. Yeah, the the black and red wire um, differentiates between the positive and negative respectively. Yeah, and also the color jumper wires that go from the Raspberry Pi's GPIO headers directly to the control pins on both motor drivers. This, or you can see it inversely, going from the motor drivers to the Raspberry Pi GPIO pins. And one ground wire connects from the motor power system to the GND pin, uh, which is the physical pin number 6 on the Raspberry Pi to ensure a common ground. Yeah, basically this is the layout that shows both the logical control connections and the power distribution. And hopefully this will help you to wire the the car smoothly. Note, this diagram along with the components, images, code, and more will be available in a GitHub repository. I'll include the link in the description of this video so you can check it anytime. Let's dive into the assembly of our car. We'll begin by preparing the motors. The first step is to solder wires directly to the terminals of each motor. Make sure your solder joints are solid and isolated. And once the motors are ready, we move on to mounting the two L298N motor drivers onto the chassis. So position them where they are easy to access and stable, ideally near the motors to keep wiring tidy. Next, connect each motor to the corresponding terminals on the L298M boards and pay attention to the wiring order to ensure correct movement later. With the motors connected, it's time to add the battery holder to the chassis. To control the power flow. Install a simple switch between the battery holder and the motor drivers. This will give us the ability to safely power the motors on or off without unplugging wires. And then connect the battery holder leads to the power input terminals on the L298 and motor drivers. And yeah, now let's prepare the upper structure. Attach the camera mount to the front of the chassis. This will hold our Raspberry Pi camera for vision-based tasks later. And then add the spacers or support structures where the power bank will sit. This keeps it elevated and secure. Once the supports are in place, mount the power bank itself, aligning the USB-C port for easy cable access. And with the base nearly done, we will tidy up the motor driver wiring. So wire the control pins on both L298M boards and group them neatly to keep the layout clean and accessible. Now mount the camera onto the tilt support we installed earlier. Tighten it just enough to hold the angle, but leave some room for adjustments. Next, place the Raspberry Pi 5 onto the spacers above the power bank area, giving it good clearance and airflow. Connect the grouped motor driver control pins to the appropriate GPIO pins on the Raspberry Pi, according to the wire schema. And yeah, to keep the Pi cool, attach a fan cooler to the top. This is especially important if we in the case we'll be running intensive code, which is the case. Then connect the camera ribbon cable into the camera slot on the Raspberry Pi. And finally, plug the USB-C quick charge cable into the Raspberry Pi, using the power bank as our mobile power source. And just like that, the smart car is fully assembled. We are now ready to boot up and start programming.